Welcome to this video on mobile databases. Today, we'll dive into what mobile databases are, why they're crucial for app development, and focus on SQLite, the most widely used mobile database. My name is Muhammad Al-Rahwanji, and today I'll be your guide through technical details about this topic in a simple and easy to follow way. So let's get started. So you might be asking yourself, what is a mobile database? Well, mobile databases are especially designed to handle the constraints of mobile devices, such as limited memory, battery life, and processing power. They enable apps to store data locally, provide offline access, and sync when online. For example, take a fitness app, right? Now, a fitness tracker would store your exercise data locally when there is no internet connection, and later on would sync whenever there is an internet connection. Some popular mobile databases are SQLite, Firebase, Couchbase Mobile, and Realm. Now, there are several options, as I've just mentioned, each with unique strengths. For example, SQLite is a relational database, and it's great for storing structured local data. Realm focuses on object-oriented storage, while Firebase excels in real-time syncing. And Couchbase is ideal for large-scale enterprise applications. For instance, SQLite would be ideal for an offline notes app, while if you were making an app like, let's say, a chat app which requires real-time updates, you would be better off to opt for using Firebase. Now, I'll be focusing on SQLite because it is a very popular database, right? Now, why is it so popular? SQLite remains the go-to database for mobile apps because it is embedded, lightweight, and serverless, making it highly efficient for offline-first apps. One of SQLite's key features is its ACID compliance, or ACID compliance. I honestly did not know what ACID was before making this video, so I'm gonna take a little bit to just talk about what ACID is. Now, the A stands for atomicity, ensuring that a transaction is all or nothing. For example, if you're transferring money between accounts and one part of the transaction fails, the entire operation is rolled back, leaving no partial changes. The C stands for consistency, meaning that any transaction brings the database from one valid state. Any transaction brings the database from one valid state to another, while adhering to all rules and constraints. I stands for isolation, ensuring that transactions happen independently, so one does not interfere with the other. Lastly, D stands for durability, which ensures that once a transaction is committed, the changes are permanent, even if the system crashes. These properties make SQLite not only reliable, but also a safe choice for managing critical data. For example, it is used in messaging apps to store chat histories locally, allowing users to access their messages offline. Now that we're done explaining what ACID is, you might be wondering, how does SQLite work? Well, let me answer you. SQLite is a serverless database, as I've just mentioned before, where all data is stored in a single file, making it portable and easy to back up. It supports SQL, so queries like creating tables, inserting data, and retrieving records are simple and familiar. I've included an example right there on the slide of some basic SQL queries you would make on SQLite. So the first line here inserts into a table called users the name Alice and the email alice@example.com. The second line we have here simply selects all records for the selects all records from the table users and displays it. I'm sure you're familiar with these queries, but I just wanted to add an example for you to see. These features make SQLite both powerful and easy to use. Moving on, I'll be giving you some examples on how to integrate mobile database. More specifically, how to integrate the SQLite mobile database. SQLite integrates easily with mobile platforms. On Android, you can manage databases using SQLite Open Helper, a built-in tool that simplifies database management. For example, you can use it to store user settings or local data caches. On iOS, developers often use core data or libraries like FMDB to achieve similar functionality. These tools ensure data is managed efficiently and help handle challenges like performance optimization or error handling. Now, in case you're interested in using SQLite database, here are some helpful practices for you to keep in mind whenever you do use it. So to get the best out of SQLite, use indexing. You use indexing to speed up queries, keep your schema simple for maintainability. Regular backups and careful handling of migrations during app updates are essential for data integrity. If your app handles large data if your app handles a large database, right? Large data sets, test the database performance under real-world conditions to avoid bottlenecks later on. Following these practices ensures your database remains fast, reliable, and easy to scale if you decide to do so in the future. Now, while SQLite is powerful and versatile, it does come with some limitations and challenges. One key limitation is that it's not ideal for apps requiring high concurrency, where multiple users or processes need to access the database simultaneously. This is because SQLite is optimized for local single-user environments. Another limitation is scalability. While SQLite works well for small to medium datasets, it's not designed for large-scale distributed systems, like those supported by server-based databases. Additionally, SQLite lacks built-in real-time syncing capability for apps needing collaborative functionality or multi-device sync. Developers often need to implement custom solutions or combine SQLite with cloud-based databases like Firebase. Despite these limitations, SQLite remains an excellent choice for many mobile applications, especially those with structured data and offline-first requirements. To see SQLite in action, consider mobile browsers like Firefox and Chrome, which use SQLite for local data storage. Similarly, many messaging apps rely on SQLite to store Many messaging apps rely on SQLite to store chat histories offline, ensuring seamless access. Fitness apps are another great example I've mentioned before, where SQLite tracks progress locally and syncs data later when online. These real-world examples highlight why developers consistently choose SQLite for its reliability and efficiency. Now, as I reach the end of my video, I would like to review the key points I hope you have learned with me here. So, mobile databases are indispensable for creating efficient and reliable apps, and SQLite remains a robust choice for most offline and structured data needs. However, it's important to be aware of each database's limitations and strengths. Alternatives like Realm and Firebase can address specific app requirements, such as real-time syncing and whatnot, so you have to check your needs before settling on a mobile database to use. Thank you for watching. I hope this video helps clarify your understanding of mobile databases, even got you interested in trying them out. If you have any questions, feel free to drop them down in the comment section, and I will be sure to answer them to the best of my ability. And that will be all for this video. Thank you.